Thank you for inviting me. I always enjoy talking to clubs around the country and about antennas and other things. So we'll get right into it here, but we're going to be talking about low band receive antennas, and we'll talk about big ones and small ones, and hopefully we can find one that'll fit into your yard. Okay, so here's what we're going to cover. We're going to talk about what the low bands are and why you want to operate them, some of the challenges, and the main part will be on different types of receive antennas that you can use to help you make more contacts on the low bands, and some other things to keep in mind if you are going to be putting up a low band receive antenna. We'll start the big antennas and work our way down when we get to that part of the talk. Mel covered the my bio pretty well. Little thing, I'm probably best known for my column Contest Tips, Tricks, and Techniques, which ran in the ARL's National Contest Journal. I wrote that column for 35 years, and after a year or so ago, I decided it was time to hang that up. My company, Unified Microsystems, started out as as kind of a moonlight consulting thing, but I had a home project that got out of control, and the ARL heard about it and wanted me to write an article, and then they suggested I sell kits, and then I got involved with FCC testing to sell them, and it just kind of snowballed from there. And I just do projects, mostly kinds of things that I like or I really kind of find interesting. And we will talk a little bit about some of the low band antenna products I have, but this is not going to be an infomercial. There'll be a survey. We'll talk a little bit about my products, but hopefully you'll get a lot of stuff out of this talk, and I certainly encourage people to build their own home brewing. I'm a member of a lot of different organizations. Here's a few of them I'm at right now, and I just live northwest of Milwaukee. So we'll get into it. We'll talk about the low bands and why should we operate. Well, first of all, most people consider the low bands 160 through 40. Some people include 30 meters. I kind of consider 30 meters a transition band. It has some of the characteristics of the higher HF bands and some of the characteristics of the lower ones. And certainly a lot of people use receive antennas for lower bands to effectiveness on 30 meters. The low bands are probably most important to us as hams because they're very reliable for the short and medium range communications. So you see a lot of the nets and the traffic handling nets and things, they all tend to be down in the low bands. A lot of reg choosing schedules, people will schedule those for those bands. And as DXers, you all know that we can work DX at night, under the right conditions. We can work around the world on the low bands. It's a little bit tougher, but that's part of the appeal. It's a challenge. And also, if you're a contester like me, you want to have an effective station on every band. So that's another reason that I'm on 160 and 80 meters and 40 meters. So what are the biggest challenge for receiving on the low bands? Well, in one word, it's noise. We have static caused by thunderstorms. I don't know how bad you get it out there. I'm sure you do have it. But around here in Wisconsin, we can have a thunderstorm in Texas or Arkansas that'll just totally wipe out the band, or a hurricane in the Gulf, and we just can't hear anything with 30/9 static bursts. We'll tend to have more QRM on the lower bands than we might on the higher bands. On like 15 or 10 meters, you aren't going to hear guys that are several hundred miles out to maybe 1,000 miles out because they're in a skip zone. But the skip distances on the lower bands are shorter, so you're going to hear more of the stations that are on the air at a time. An increasingly big problem is RFI from digital devices. Switching power supplies are really the bane of HF operating, especially on the lower frequencies. Plasma TVs have been a source, but fortunately that technology is kind of obsolete, and they have to be recharged over time, so it's just cheaper to replace it with a newer one. So plasma TVs were a problem, but are less of a problem right now. But even things like cell phone chargers and wall wart supplies can be a problem. I was operating a contest a couple of years ago, and all of a sudden the noise just jumped way up, and I went upstairs and asked my wife, did she do something? Well, she just plugged in her phone to charge it. Well, I was able to remedy that problem with a large hammer, but it can be a problem. Home appliances and lighting can be another problem. For whatever reason, the FCC doesn't have a stringent RFI restrictions on home appliances. I mean, there's very few, and those can sometimes be a problem. Solar power systems, some are clean and quiet, and some of them are very noisy in inverters. And a growing concern is the wireless chargers for electric vehicles. When you start putting 10 kilowatts of power and you're trying to charge a battery through a magnetic field, you're generating a lot of radio waves. And the ARL is very concerned about this, and they've got a task force that's out there just to address the situation, hopefully get some requirements that they don't pollute the airwaves. So we have a lot of noise problems. So how do we hear through that? Well, a low band receive antenna could be the answer. As I mentioned, it can be very large or can be quite small. There's a lot of different parts and types available. A few of the resources, the ARL Handbook, ON4UN's, Low Band DXing book. The KL7AJ has got a fairly decent book. It's published by the ARL on receive antennas. And of course, there's a lot of information on the internet. Of course, some of it's not always that good. And you can homebrew those, and there's also commercial versions available for most of the types of antennas we'll discuss. And most of them are fairly simple. And if you like to do homebrewing, you can get a lot of bang for your buck with a low band receive antenna. Well, if you want to understand a problem, the first thing to do is you want to understand what's actually going on and what are the noise considerations. The first thing is that low band signals are often very strong. They might be S7, S8, S9. The problem is if the noise is S9 or 20 over, then you're going to be hard to copy. And the real key is the signal to noise ratio. So if you're S9, but the noise is 30 over, the QRM or where it's 30 over, you aren't going to be heard. On the other hand, if you're up on 10 meters, a lot of times you can have a station that's not moving the S meter and be perfectly Q5 because there's just no noise. So the signal to noise ratio is really the limiting factor in these sort of communications. Now, receive antennas don't have any gain, like we think about it as a Yagi might have an 8 dB gain or whatever, but they do have directivity. And not only do they not have gain, a lot of them have negative gain. Many of these antennas are only like 1% efficient, which means they'll be like 20 dB down from your transmit antenna as far as signal strength. But if they attenuate the signals in other directions or the noise from other directions more than they attenuate the signal, you improve the signal to noise ratio. And worst case, maybe you just have to turn the volume up a little bit. So that's really the key, is to increase the signal to noise ratio by reducing the noise coming from other directions, even if it does mean a reduction in the signal itself. Now, there's many types of low band antennas. We'll be talking about beverage type antennas. We'll talk about large loops and small loops. We aren't going to cover a couple other ones that are out there. Vertical arrays. Essentially, you have a array of 3 to maybe 8 or 9. And there's a couple different types. There's the untuned ones, and then there's the tuned ones, which are just set for one band. They're generally short verticals, maybe under 20 feet, maybe even only like 6 or 8 feet. And a lot of times will require amplifiers, and that's kind of one of the downsides on them, because they're expensive for needing all the phasing lines and the amplifiers, and you have to worry about the amplifiers getting blown up by nearby lightning strikes and whatever. Waller flags are another. They're not very common. They're pretty large. If you put them up horizontally, they have to be up over 100 feet. I know at least one person that has one who likes it. But if I had a 100-foot tower with a big antenna, I think I'd prefer a 20-meter beam rather than a Waller flag. But hopefully one of these will fit on your property. It might be of interest to you if you don't already have something. We'll start with beverage antennas. They got the name from Harold Beverage, who was an engineer at GE. It was around 1919, 1920, he invented it. They were working at putting out radio telephone stations between Europe and the United States. They didn't have fiber optics or all that good stuff. They had some submarine cables that could do Morse or telegraph, but they were very limited in the bandwidth. So they were looking at ways to improve communications by radio between the two continents. And he came up with the beverage antenna to help for receiving. Beverage antenna is just essentially a long wire, several hundred feet long normally, with a terminating resistor at the far end. Now, ideally, they're around 3 or 4 or so wavelengths long, but they can have some improvement even at a half wavelength or so. And these are known as wave antennas, and we'll talk a little bit about how they work in a second. But the Beverage is kind of considered the standard, the gold standard that other antennas are compared with for low band receive purposes. Here's a picture of a typical Beverage. See, we have a terminating resistor of a long wire that, like I said, usually several hundred feet long, transformer at one end, and then ground rods here. Now, if you stand at the transformer end and you look at the terminating resistor, you are now looking at the direction of the favorite receive direction. So if you wanted to, from here, if I want to have one to Europe, I'll point it north, point the terminating resistor to the northeast of my coax. It's about 45 degrees from Wisconsin. So how do these work? Well, if we have a vertically polarized signal coming in, traveling in this direction, it's going to start to get tilted. It's kind of like it's dragging its feet and kind of falling forward. And that's because the velocity factor around the ground is lower than it is in free space. So down here, it's traveling slower than it is here. So this starts to lead. And because of this tilt, we can build up a current along this wire. And as the wave traverses along the wire, this gets larger and larger. Current goes to the transformer, it gets converted to your coax impedance and sent to your receiver. So we're receiving the signals very well coming from this direction. Signals going from the other direction will be just kind of the opposite direction, but they'll be still tilted, and they'll build up a signal. But then it'll hit the terminating resistor, and it'll be dissipated as heat into ground. So we aren't going to get any signals that come from this direction. Now, signals coming from the sides are going to be hitting this antenna pretty much straight on, and we're not going to have any differential because of it's all in the same plane. Or if you look at it from a wave standpoint, if it takes several hundred feet to get up any sort of a signal, built up going this way, the diameter of the wire isn't going to do anything at all as far as picking up a signal. And even though this antenna is horizontal, it's actually a vertically polarized antenna. It's kind of a surprise to some people. So here's a pattern that I modeled with EasyNet for 160 meters. It's a 500-foot Beverage. It's about 7 feet off the ground, 470 ohm termination. That's pretty the standard. Typically, it'll be between 450 and 500 ohms, and 470 is a standard resistor, so that's what's used. And this is a plot at 30 degrees. So if we look at the specifics here, at 160 meters, that 500 feet's only about 1.1 wavelength, so it's pretty short. The gain is minus 15.6 dB isotropic. So if we had one of the theoretical isotropic antennas, which is it has no gain and radiates and receives equally from all directions, this signal would be about 2.5 S units down from the isotropic. Front to back's pretty fair. It's almost 20 dB. The beam width is pretty wide. It's about 100 degrees, so it's a pretty big beam width here. Now, if we use the same antenna at 80 meters, now we're close to 2 wavelengths long. We can see that the gain is down at minus 6.7 dBi, which is basically about a dB, I'm sorry, 1 S unit less than our isotropic antenna. Front to back seems to be about the same, but you can see that the beam width is much narrower. So it's going to be like pulling this out and be more gain or really less loss, but it'd be also narrower. Going down to 40 meters, we see now we're about 3 3/4 wavelengths long. We're only down less than half an S unit, and the front to back's about the same, but you can see that's also much narrower. Now, the front to back here is a little bit misleading here on as we go up in frequency and the number of wavelengths increases. You can see what the back looks like on 160 meters, but as we start getting longer for the frequency, we start getting some spikes that'll be occurring in here. The more spikes, the higher the frequency. So we'll have some nulls and some peaks, so it'll be a little bit rougher back in the back. It won't be as clean a pattern as we have on 160. Some notes on putting up a beverage. Well, longer is better, but at some point around 5 wavelengths, you start reaching a point of diminishing return. I have a beverage at 350 feet, and it's not as good on 160 as is an 80 and 40, but it's certainly, uh, I would not be making the contacts I make without it, or it's, DX-wise. Normally, you want to keep these above the high enough so that people don't run into them or deer run into them. Deer are a big problem out here. 7 to 8 feet is pretty common. Now, if you don't have perfectly flat land, what you want to do is try to follow the terrain. So if you have a ditch of any sort of a length or hills or whatever, make your support so that the wires pretty much follow the terrain. If you have something, you got to make a short jog around or go up or over a driveway or something like that. If they're short, then that isn't going to have too much of a problem. It's not going to hurt that much. Like all receive antennas, you want to keep them away from other metal objects to keep coupling noise into it. Now, beverages work actually better in poor soil than good, highly conductive good soil, unlike transmit antennas. I had one customer that bought one of my BevFlex systems, and he was very unhappy because it didn't work very well. Well, it turned out he lived in Florida in one of the canals and whatever. And every day at high tide, the water would run up over the soil under his beverage. And so it's getting a constant refreshment of seawater, which is pretty conductive. So that it didn't work very well. Now, these rules up here are use them as guidelines. Do what you can, but don't get too stressed out if you can't meet each one of them. I mean, beverages really, really want to work no matter what. They just want to work. So if you aren't perfect, they'll still work very well. Jeff, W8GM, which we'll talk about a little bit more later, gave a talk at the August 21 QSO Today conference on beverage antennas, and he looked at things like sloping them, doing vertical zigzags to increase the length, and short jogs around objects to get around them and stuff, and found that as long as they're reasonable, they didn't really affect the performance all that much. So they said beverage antennas just really want to work. You can make these things easy enough, the transformers and the resistors. If you don't want to make them yourself, you can buy them. I sell a couple of products for that. The BT75 beverage transformer. And I also have a terminating resistor for 470 ohms. I also have some 270s and 1,000 ohm ones for if you're making a different type of an antenna, but they're putting NEMA rated enclosures with the rubber gaskets to keep the inside secure, the stainless steel hardware, coat the circuit boards and the internal electronic. Oh, there's no circuit boards in these, but coat the internal electronics with conformal coating for additional protection. There's gas discharge tubes for protection against nearby lightning strikes. I'll talk about gas discharge tubes later. Terminators use 2-watt high surge non-inductive ceramic resistors, so they can take a lot of use. And these are available from DX Engineering and Ham Radio Outlet. Now, another form of the beverage is a beverage on ground. Rather than putting it up in the air, why don't we just lay it on the ground? Well, that actually does work. There's a few things that are a little bit different, some pluses and some minuses compared to the classical elevated beverage. First of all, don't bury it. If it gets covered by dirt or snow, you'll start having some degradation. It's actually better, quite a bit better, if you can put it a few inches off the ground. Actually, a beverage, the ideal height for a beverage is around 3 or 4 feet, but it's just too many problems with animals and people and stuff, so you don't see many of them at that height. But if you can put it off a few inches above the ground, I know people that have fences and they can basically mount the thing off the fence a few inches, and they see an improvement by moving it up. But one of the advantages of the beverage is because they can be shorter, or they're physically shorter, because as we mentioned before with the beverage, that the velocity factor of soil is less than it is in free space. So 90 feet to 250 feet are popular lengths, where if you're doing an elevated beverage, hopefully you start at 250 feet and go from there. I've heard that some people that have used these things and studied the beverage on ground or the bogs that 225 feet is about an optimal length for 160 meters. So this might be a possibility if you don't have the real estate to put up a regular beverage. Other advantages, they don't require supports. They're more stealthy. They might be a trip hazard, but probably your HOA isn't going to notice if you have one of these things, or they might if you have several hundred feet of or more of posts and wire. Lower impedance one of these 270 ohms. One of the disadvantages of the bog is that it's going to be about another 10 or 15 dB and signal strength below the elevated beverage. So you might need a preamp, especially if your beverage is on the short end. There's a number of type of loop antennas that are popular. The K9AY may be the most popular. There's flags, pennants. There's the U or EWE, depending on how you pronounce it, and the V3DO. Now, these antennas, unlike the beverage, they work more like closely spaced verticals. We'll start with the K9AY array. It was developed by Gary Breed. Gary lives about 100 miles from me. Very sharp guy. And these antennas are essentially two diamond-shaped loops at right angles, and they're instantly switchable in the 4 directions, which makes them very nice. They don't take a lot of space. You only need a space about 25 by 25 or so, and a single support about 25 feet high. It can be a pole or a tree bench. One of the guys in my local club decided he wanted to put one up, and he hung it from a tree, and his wife had told him earlier that no more antennas were going to be allowed, but he put it up there, and it took her about 3 years to even see it. So they can be stealthy. Here's a picture of one, or a diagram of one. You see the diamond shape, and we have a terminating resistor on one side and a transformer on the other. Now, if you remember in the beverage, I said if we stick the transformer and look towards the terminator end, we're looking at the direction, the best direction for the signal. Well, these are the opposite. If we look at the transformer side towards the terminating side, we're looking in the direction of the null. So signals coming from this direction will not be picked up as well as stations coming in from this direction. Now, you notice we have a ground rod and the terminator and transformer are right next to each other. If we're clever, we could put some relays in there, and then we could swap the terminating resistor and the transformer to the opposite sides, and now we reverse the direction. So if we put another one of these things at right angles into the relay, now we can instantly switch into 4 directions. This is a picture of the one I have here at W9XT. I have this is made out of PVC tubing, and you can kind of see the wires coming off over here. Down here, and this is the box that holds the electronics. I've got it set up to switch northeast, southeast, southwest, and northwest. I use RG6 75 ohm coax for the feed line. I really like 75 ohm coax for feed line, and we'll talk a little bit more about that later in the talk. And I've never felt the need for a preamp with this antenna. Here's the box, a close-up. Now, actually, this is an old picture here. These are an older design. This is my current one. You can see the relays here. We have the terminal blocks, the coax, and the wire ends, and the control lines for the relays and the terminator resistor. Here's the transformer by binocular type ferrite isolated windings. This is a gas discharge tube. When I first started playing with the K9AY array and beverages, I had a problem that most of the time, sometime in the summer, the thing would stop working. It'd just be dead. I couldn't hear anything out of it. And I'd open them up and everything looked fine, but if I replaced the transformer, it looked perfectly fine, but replacing it and all of a sudden started working again. And the only thing I can think of is we probably had some surge from a nearby electrical lightning strike that did something to change the characteristics of the ferrite. So I started putting in these gas discharge tubes. They're pretty inexpensive, and I've probably got somewhere between 800 and 1,000 different units of receive antenna parts that have those in there, and I have not had one yet returned because it got burned out. So if you're homebrewing one of these things or any sort of a receive antenna that uses a transformer, I suggest you put one of these on it. You'll notice a second board here on the inside. Some people have found that you can get some better rejection by changing the impedance of the terminating resistor. So I built up a little board with a bunch of resistors and some relays, and I could select different impedances, I think I went down from around 200 to around 800 or 900 ohms. It's been quite a while. And I could select different ones in there. And sometimes it did help, and sometimes it was over an S unit improvement. But it only seemed to work if the station was exactly on the back of the beam. It was off the side a little bit, changing the terminating resistance really didn't seem to have any effect, and it never really had any effect on the signal strength of the received signal. So if you really want to have some optimization, you may want to play around with it. But I didn't really feel that it was really worth the effort from my experiments. But it's an interesting thing to experiment with. Here's a schematic of the one I did. It's changed a little bit from the original K9AY design. This is on my personal website, W9XT.com. If you want to take a closer look and some more detailed information about it. Basically, I have the transformer. Now, the original transformer that Gary had was a single coil that was tapped for the right impedance. And it's pretty well agreed that having separate windings is much better from of a noise standpoint. Having those the primary and secondary isolated is a big help. Here's where the gas discharge tube is. He didn't have one on his. Now his design fed power through the coax. If he had 0 volts on there, none of the relays would be energizing. But 12 volts on with some diode steering, it would energize one relay. If you put negative 12 volts, it would energize the other relay. And if you put AC on, it would energize both. I have not had much luck with using bias Ts and putting DC voltage on coax on low band stuff. I've tried some remote switches with it, and I just picked up a lot of noise. I thought, well, there's a power supply. Well, I tried it with a battery, which is obviously a very pure DC signal. That didn't seem to help much. And, probably I did something wrong, but I've just kind of come to the conclusion if I'm going to be running a piece of coax out there, running some some wires to control the relays, and just avoiding that problem is worth it. And I use the variable Cat5 computer networking cable. That stuff is fairly inexpensive, and that works fine because you're not putting a lot of power through there to do the relays. So anyway, this is the design that I used for my K9AY system. Some of the other versions, the flag and the pennant, you can see that there's articles in QST. There's single direction. Again, the null direction's in the direction of the side of the terminating resistor. It's just kind of different supports you need. The flag and the pennant are typically put about 8 feet off the ground. So you're going to need 2 supports, and they're both pretty high in the 25 feet. So I kind of prefer the K9AY because I get 4 directions with a single support. Now these are terminated by 1,000 ohms, and they're pretty broad, but some people use them and they're pretty happy with them. So some similar versions are the EWE or U. It's kind of like a flag, but it's on the ground, and it kind of uses the ground as the complete the loop. So this isn't quite as high, and then the standard is 15 feet high and 40 feet long. The V3DO version, essentially, instead of using the earth as the ground, it brings in some wires to complete the loop. So now you only need 1 ground rod, and he has different designs that are optimized for 80 or 160, both in the length and the height off the ground. Another antenna that's gotten popular, and one I haven't used, KK5JY is kind of the one that's made this popular. He's got a website, and he describes the antenna pretty well. It's very interesting, and it's essentially just a square loop that's on the ground. You feed it in a corner, and it's you can see the direction, its directivity. It's bidirectional. 15 and 30 feet seem to be the standard ones. From the people that have used these things, they seem to think the 30-foot one is bigger. I don't know if there's anything magic about 15 or 30. If you made it 25 or 35, I really don't know how much that'll change. Like, I have not used one of these. It's kind of on my list. I know I have a couple of customers that bought my BT75 transformers and use them, and they're very happy. I think there's a review on the DX Engineering reviews. He talked about it, and one of my friends about 15 miles ago, he's got a small yard, and he put in two of these things so he can get two different directions, and he used the same transformer, and he's very happy with it. Now, these things aren't going to, outperform, a loop, or certainly not a long beverage, but if you don't have a lot of room, and this thing's certainly very stealthy, so it might be an option. And you'll want to use a transformer to feed it, similar to like you would use for the beverage. Now, here's another antenna I have not used myself, the small magnetic loop antennas. One of the advantages are usually they're rotatable. They're so small, usually 3 or 4 feet are typical sizes. They will require a preamp because the signal is not going to be very strong. They're bidirectional. So if you want to work, say in your area, you want to work Japan, and your neighbor's got a plasma TV and he's to the southeast, and this antenna may not do you a whole lot of good. But a lot of times these people use them mostly just to null out a noise source, and you notice that the null directions are opposite the plane of the antenna itself. And like I said, you get to homebrew, and there's also a number of commercial designs that are out there. Now, one of the problems with things like beverages is it's kind of hard to rotate 1,000-foot beverage. It really requires a big rotor. But there are some designs that use 2 wires, and one's terminated, one's unterminated, multiple transformers to get 2 directions. And there's commercial or homebrew antennas that you can do this. I had one. I wasn't real happy with it, so I went with the single wire, but in dismay, I didn't do something wrong. Jeff Mendenhall, W9XT, he's a really sharp RF guy. He worked in the broadcast industry and still does consulting. He has all sorts of technical awards. He came up with something called the BevFlex, and it's a really unique antenna because it's inherently switchable in 2 directions. And the thing that's different about it is it uses RG6 coax for the antenna element instead of wire. And like I said, it's switchable in 2 directions. But one of the really cool things is you can feed at any point along the length of wire. And like a beverage, you have to feed it at the end. And you can also configure it as different flag, like or loop antennas like the flag EWE or the V3DO. Several years ago, he and his business partner, Ned C4X, came to me. They were having these produced by a company, but they decided to get out of the ham business. So then he went to another company, and they make excellent antennas, but they were more known for their, cutting aluminum and making Yagis, and they were doing things with circuit boards and electronic enclosures. It really wasn't in their wheelhouse, and they were having trouble keeping up with demand. So Ned had bought some stuff from me, and so I thought, well, he wanted to talk to me if I was interested in producing these things. So we talked for a bit, and they sent me one, and I played around with it. And what kind of convinced me was that the expedition to VP6 a number of years ago. And I had this thing set up northeast southwest as a bog configuration. And I would not have worked VP6 at 160 meters if I didn't have that antenna. So I pretty much decided that, yeah, I'm interested in this. I was not real happy with the packaging of the design. Earlier in my career, I worked for a contract electronics manufacturer. I managed the design group. We designed products for companies, and then we manufacture them. So, but even though I wasn't directly involved with manufacturing, I certainly learned a lot because if I didn't make the product manufacturer, the production manager would come after me with a baseball bat. And in a later job, I was hired to solve some technical reliability issues, and then they found that I had some manufacturing experience, so they also put me in charge of manufacturing. So I redesigned the packaging with Jeff's, looking over the actual design, which didn't change, and we made it a lot more reliable and waterproof and cheaper and easier to manufacture. And so now we have the BevFlex, and you can get these things from DX Engineering or HRO. And here's kind of up here, you can see the different parts. Here's a block diagram. Now we have our long antenna element, just like the Beverage. But we have these terminator units at both ends, which go to a ground rod. And somewhere in between there, we put the feed unit here. Now this can go anywhere you want. I have one where it's more convenient to feed at the end, so it's about a foot from the end, and I've got another one where it's near the center, where it gets closest to the house. So that's just a really neat feature. Now, how these work is just pretty much like the regular Beverage, but you have to remember that coax has 3 conductors. People think it's got 2 conductors, but it actually coax has 3 conductors. You have the outer shell, you have the inner wire, and you have the inner part of the shell. So what happens is if we have our signal coming in and it gets tilted just like it does with a regular Beverage, and we build up the signal, but it gets to the terminal unit, and there's some transformer in here, and that takes the signal off the outer part of the shield, converts to 75, and then injects it into the RG6 coax. So the RG6 coax is both the antenna and part of the feed system. It just uses the different 3 conductors differently. So this signal goes back down the coax where it gets to the feed unit. The feed unit strips off the signal coming from this direction and send it to the shack. Now signals from the other direction are going to do the same thing, build up in the signal in the shield, get transformed, injected in the inside of the coax, stripped off here, and it goes to a control unit in the shack. And then you have a switch here which selects whether you want to be in the forward or reverse direction, and also terminates the unused one so the signal doesn't reflect back out and mess up your pattern. That's a really clever design. I wish that I had thought of it, but I built them essentially under a license from Jeff. Now this is a very flexible antenna. You can also do the flag or a V3DO or an EWE. Here's just the diagram. We won't talk about this, but if you're interested in playing around with different ones, you can buy the BevFlex and play around with different antennas and see what you like best, all with the same hardware. We also have a 4-direction unit called the BevFlex 4X/Q. Essentially, it's 2 different BevFlexes with the terminator and the feed units, 2 sets, and then we have a switch. It's a 4-to-1 switch designed for receive antennas, and that send you back your single coax. And of course, you have your control lines. And you don't have to make these antennas the same. This could be a bog, and this could be a flag, or you could have 2 beverages, or a beverage and a flag, or whatever combination you want with this system. It's very flexible. So if you're going to put up a low band receive antenna, there's some things you want to keep in mind, and we're going to cover those here next in the next section. The first and most important one is protecting your receiver. If you have a remote receive antenna coming into the receive antenna slot of your radio, you can burn that up. Or if you have a second receiver, you could burn that up if the antennas are too close or you're running too much power. You can get a pretty good signal there. The first thing to do is try to keep them as far apart as possible. Of course, that's one of those things that's all relative. Consider using a protection device. There's someone that just basically switched the antenna out, short it out, or disconnect it from the received antenna jack during transmit. And there's also some that are RF limiters that will tend to reduce any high signal levels. The BevFlex, the control box, has some additional protection from that, but if you're running in a kilowatt close to a receive antenna, you probably want to do more. And DX Engineering does have some of these limiters that are made by their companies. And like with any other antenna, you want to disconnect it if you got thunderstorms in the area. You want to keep your receive antennas away from other metal objects, especially transmit antennas, because and especially vertical type conductors, because they can inject noise into your system. If you have something like a vertical or inverted L, and you have radials, you don't want to run a Beverage over those radials, and you'll pick up too much noise. If you have an extreme case, you want to consider detuning your transmit antennas or your towers when you receive. Now, some people say, well, how far apart should I keep my receive end from my other stuff? Well, ideally, like a wavelength, we're talking 500 feet on 160 meters. So that's really not very practical for many of us. Just do the best you can. Don't 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 worry and not put up one of these things because you can't meet perfection. Don't let the perfect be the enemy of the good. Talk about feeding receive antennas. Like I mentioned, I like 75 ohm RG6 coax. It's used for the cable TV. It's very inexpensive. This stuff goes up to a gigahertz, so it's going to be really low loss. You can get the self-sealing flooded types, which can be useful if you have rodents and other critters that like to chew on it. Now, there's two types of RG6 coax. There's the dual shield and the quad shield. The dual shield has a metallized mylar shield with a metal braid, usually aluminum, around that. Now, the cable TV companies found out it was difficult to meet their leakage specs with a regular dual shield RG6, so they went to a quad shield, which is got a second layer of mylar followed by a second metal shield, wire shield. Now, the important thing is whatever type you use, get the right type of connectors. If you use the quad with the dual or vice versa, you're going to have a real mess. So which one should you get? Well, my feeling is if I have a roll of the old dual stuff and it's still a good shape, I'll use that. But if I have to buy new coax, I'll get the quad because it's not that much more expensive. They're a little bit hard to find, but there are the connectors that have gaskets that are designed for outdoor use, and if you can find them, then use great. And of course, like any other antenna, regardless of the gasket or not, you want to do a good job weatherproofing the connections. Another question I get is, do I need a preamp? Probably not, unless you have like a small loop or maybe a short bog. Maybe some older rigs could use a little bit of a gain. If you have a really, really long coax, maybe it would be beneficial. My bog is about 120 feet or so, and so it's a little bit on the shorter side. And sometimes when I have that one on there, it's a little bit could use a little bit of gain. I have a Yaesu FTDX 5000, and it's got a special preamp to be used on 10 meters or 6 meters where it's very quiet, where a little bit of extra gain. Now, you'd be crazy to turn that thing on the low bands with a regular antenna because you're just going to overload the signals. But I found it's perfectly adequate for additional gain when I use that antenna and I need just a little bit more. Now, suppose you decide you do need a preamp. So what should you look for? Well, there's three things that they're going to specify a preamp. One is gain, one is noise figure, and one is dynamic range. Now, the first thing they're going to tout is gain because gain is cheap to get. They'll usually say it's got 20 dB or more. Usually, you probably only need 10 or 15 dB. If you want that variable gain, that'd be good. If you have one that has like 20 or 25 dB, you might want to put in some sort of a selectable attenuator if your radio doesn't have one built in. Because too much gain is just going to cause overload and intermods and just generate a lot of noise. Another one they might tout is noise figure. If you do VHF or UHF weak signal work, moon bounce, that sort of thing, you're probably aware about the need for preamps, the low noise figure. And the reason those help is because up on those high frequencies, the atmospheric and space noise or whatever is often lower than the noise that's generated by the front end of your receiver. So in that case, if you have a very low noise figure preamp, you can increase the signal strength for the same noise to front end, so you're increasing the signal to noise ratio. But if we're talking about, very, very low levels of noise at those frequencies in your front end, well, on 80 meters or 160 meters, the atmospheric noise is very high. And if the front end of your receiver is essentially generating S8 or S9 noise from that stage, you've got more problems than with the radio. You don't need to be worrying about preamps on your receive antennas. The most important spec is the dynamic range, which is how well it can handle strong and weak signals without causing overload and distortion. Since you don't want the weak signals, a few kilohertz away, blotting everything out. Unfortunately, that's one spec that's rarely specified, so I can't really make a good recommendation there. And if you live near an AM station, then you might need some AM broadcast filters as well. Common mode noise can really hurt these type of antennas. As I mentioned before, coax has three conductors. We have the inner wire conductor, you have the inner shield, and you have the outer shield. Now, normally, if your feed line is matched and everything's working fine, you have a current flowing down the center conductor, and you have an equal and opposite current flowing on the inside of the shield. But if things are not quite balanced right or whatever, you can have currents flowing on the outside of the shield as well as this center conductor. It's kind of the same reason we put a balun on a dipole or a beam, is we don't want current flowing on the outside. In your transmit antenna, like your dipole, that can mess up your pattern, and you can get RF in the shack. But in our case, in the low band receive, that can generate noise. There was a YouTube video that a guy had, and I think he took it down because I haven't been able to find it the last year or so, where he took the signal coming in from his Beverage antenna and put it into a spectrum analyzer and showed all of the noise. And then he had a filter that he built where he had just coming into the house, he had a ground rod attached to the shield, and he had a whole string of these ferrite beads on the outside of the coax. And he showed the noise on the spectrum analyzer with that on there. And it was very dramatic. So you want to do things to prevent the common mode currents. Burying the feed line will help a lot. Putting ferrite chokes, beads on the coax or wrapping around a large core can help when you do that where it comes in the house or near the rig. One-to-one isolation transformers help. I have those built in the BevFlex different units to break up the coax and help to prevent any of this sort of thing from passing through. As I mentioned, I'm not a big fan of putting power on the coax to control things. But, that's something you can give a try. So you put up your antenna now and you want to test it. Well, one good way to do that is to test it in the day with some distant AM broadcast stations. The nice thing about that is that there's not going to be much QSB like you might get it during on the air at night. They're going to be constantly transmitting, so it's not like when you start to get a beat on some guy, he turns it over to other stations you can't hear. You know exactly where they are if you look them up. So find one that's about 50 or 100 miles away. You can do a search on Google for the AM stations in your state, and you'll find out their location and power and frequency. So you can test, stations that are in the right direction and off the side and off the back, and you can compare it with your transmit other antenna to see what kind of front to back and noise reduction you're getting. Now, when you do this, consider that if you're listening on the AM band, especially the low end, your wire is going to be very short in wavelengths compared to what it might be on the ham bands higher in frequency. So the beam width is going to be wider if you're listening down in the lower end of the AM band than it will be certainly like an 80 and 40. And the signals coming in will be ground waves, so it'll be a very low angle. You might be having more signals coming in at higher angles at night. But it's a good quick test, but just you have to kind of realize the limitations of that test. Some other random thoughts about receive antennas. If you put up several of these, you're going to find that one of them is going to be generally better in a certain path most of the time, but there'll be times when the other ones are better. My Beverage to Europe is almost always better than my K9AY array to Europe, but not always. And if you got something else, if you're not filling the signal through, check your dipole or your tri-bender, because maybe that night that's actually a better receive antenna. Another thing is, especially if you're a contester or you're staying up trying to find that one opening, 10-minute opening to Bouvet, is that the noise, listening to the noise is very fatiguing. It takes your brain a lot of energy to deal with that. And if you're a contester, just having low noise will just reduce the fatigue. When the first time I started using low noise receive antennas on 80 and again sweepstakes and stuff, I really noticed that I was just a lot less tired after a good session on the low bands. So conclusions, the low noise receive antennas can be a big help in your DXing. Keep some realistic expectations. A lot depends on your noise source. If you have noise sources coming in the direction of your desired signal, the antenna is not going to help much. They're not going to turn a weak signal S9 plus 10, but they might reduce the noise enough that you'll be able to copy it where you couldn't otherwise. Different options, a lot of different designs and sizes. You can homebrew them or buy them commercially. And just pick one and just do the best you can. You're not going to be able to make it perfect, but you'll find out just about anything you do is probably going to be better than your transmit antenna on most nights. Give you just a quick look here what I have at the W9XT. I got a few towers. My main tower is next to the house. I have a tri-bander and some VHF and some dipoles. Tower 2, this is 50 foot. This is 60 foot. It's got a 2-element Yagi for 40, a small tri-bander, and it's shunt fed for 80 meters. There's kind of a ridge and it drops off very sharply here. And from the tower base down to here, it's probably about a 40-foot drop off, but there's some very tall oak trees. So this is actually looking in the hills to the west and to the southwest. But the wire goes up to about 65 feet, then it goes to the top of the tower. It's not really an L. It's actually going up to the top of the tower at about a 60-degree angle. A very effective transmit antenna on 160. This is the BevFlex bog that I put up when I was testing it. This is a beverage that I've had all along. That'll probably get converted to a BevFlex this year. And then this is a BevFlex bog. I've cleared out this land over here. I'm going to put up a 4 square for 40. So I'm either going to cut this and make it shorter or put something like an EWE or something like here. I have the K9AY array here. Oh, this is a little bit outdated. I don't have the 2 meter. I put a 6 meter Yagi at about 20 feet here. I have 6 meters up here at 55 feet. And I found that a lot of times the low antenna is much better than the high antenna for working stations. W3LPL has got a very good talk about that on 6 meters. And I've got my other popular talks is about antenna takeoff angles and especially with respect to terrain and how to model it. I live on a very hilly area and the hills help me sometimes, but they kill me other areas. But for receiving, I built a receive box. Oh, I should mention, I have one of my remote switches. I have one here and I have one in the shack. And I built a box that basically selects the 4 directions, and it selects directions in the K9AY, and it selects the directions down here. And then the bog comes in on these other inputs here. So if I'm contesting like a 160 contest, I will generally CQ on the and listen to the K9AY array, and I'll have it pointing to northeast or southeast in the evening, and then I'll point it towards the western directions before sunrise, because that's where most of my answers will come from. But if I get somebody that's a little bit too weak to pull out, I'll go and I'll start switching the direction here until I get the strongest signal and the most copyable signal. And usually that'll be enough. But if it isn't, then it's probably a DX station. And if I flip it to the beverages, I'll already have the best direction selected. So it's instantly, and that almost always pulls the signal out. So that's what I use here. So that's pretty much it. So do we got some resources? If you want some information about my products here, my home personal page has got a bunch of stuff on some of my radio projects and some of my non-radio projects as well. There's more information about my K9AY and some other antennas and other stuff. So that's pretty much it. Anybody have any questions?